Welcome back. I turned my hat backwards. That's what I did over the last 15 seconds. I'm not much of a backwards hat guy. I was just trying to be funny. Move my hat back forwards. Now we're going to get into part 2 of today's lesson. Just as a reminder, part 1, let's make Elliot small. This total lesson was function notation and domain and range. Part 1 was function notation. That was a 10-minute video. If you haven't watched the function notation part, you might want to go back and watch it. We're now starting part 2 of this lesson, which is domain and range. Oops, that was the other part. And let's get into domain and range. Now, I know that you learned a little bit about domain and range in your algebra class and maybe a little bit in your geometry class. But this is a little bit of a refresher. And then there's also a new way that we'd like you to answer these problems. We're going to call that interval notation. And I'll also be explaining during this lesson exactly what interval notation is. Now, if you've done domain and range before, what you've learned is that the domain is where your x-coordinates exist, and the range is where your y-coordinates exist. This is a tricky topic for a lot of people to master, and I'm going to be honest with you. This is a topic that I didn't fully understand until I was in college, and even then I understood it, but I still wasn't particularly good at it until I began teaching. In teaching, you explain so much math to so many people on a daily basis. It forces you to get good and learn the material and learn it at a professional level. So this is something that I want you to be good at, but it might take a little time to get comfortable with domain and range, and that's okay. Practice, 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 it'll make you better. This is my first graph right here. I have a line. This line is going forever. It's going forever to the left. It's going forever to the right. I just said that backwards. It's also going forever up and down, though. It's going forever in a downless motion to the right. To the left, it's going forever up. So there's a lot of different ways that you can answer this one. I'm going to start with domain. Because of domain, it's using up every single number on the number line. My favorite answer for a domain of this variety is all reals, or all real numbers. When you get to college, you're going to learn that there's, or even upper level math, you're going to learn that they have symbols that means this, because like I said in my part 1 of the lesson, math teachers, we don't like using words if we don't have to. And there is a letter, a symbol that math people have come up with to mean all real numbers. And it's essentially a capital R with a double backbone. So if instead of writing the word all real numbers, you just want to write R, that makes sense. That works. You may have learned before that this goes all the way, the graph in the domain, in the x, goes all the way to the left, so all the way to negative infinity. So that would be less than x, which would be less than infinity. This is the old way to answer these problems. The new way is going to be interval notation. And I think if I'm going to properly explain interval notation, I think I need to actually go backwards a little bit. So I apologize. I'm going to actually back out of this. And I'm going to create just a separate side note, interval notation. Maybe call this part 2.a or something, I'm not sure. Capital V, start over. Interval notation. So let's say that you had an inequality, -3 less than x less than or equal to 8. So in this case, if you think about it on a number line, you've got 0, you have -3 here, or you have 8 here. We have an open circle at 3 heading all the way to 8, where we have a closed circle. That's kind of the old way. Interval notation is the new way. And in that one, you're basically saying, hey, from -3 to 8, this graph exists. But then how do you create a less than versus a less than or equal to? Well, for that we use soft brackets or hard brackets. So if it's less than or greater than, oops, start over. If it's less than or greater than, you're going to be using soft brackets. If it's less than or equal to or greater than or equal to, you're going to want to use hard brackets. Sometimes when a problem has both a hard and a, both a less than and a less than or equal to or greater than or equal to, you're going to use multiple ones. So in this particular case, it was going from -3 to 8, but it was not including -3. So we went with the soft bracket on the -3 side, but it did include 8, so 8 got a hard bracket. And that's kind of what interval notation is. Ask some questions to me about it on Monday if this was not clear. Okay, so getting back into the domain and range problem that I was in the middle of working. Where did it go? It's right here. So answering this in interval notation, because it's less than, because you cannot be equal to infinity, you'd say that this graph goes from -infinity to +infinity, but because it cannot be equal to infinity, you'd use soft brackets. So in this particular case for domain, it's okay to answer all real numbers. It's okay to answer with the, with this all real math symbol. It's not okay to answer it using the old way of doing an inequality. It is okay to use interval notation though. And that is the domain for that one. I'm running out of space, so I'm actually going to do number 2 on a separate piece of paper for my range on the same graph. It's same thing. This graph goes forever up and forever down, so you could answer it any. Well, in this case, all of these same answers apply. You could go with all real numbers. You could say all real numbers, but use the math symbol for it, double backboned R, capital R, or you could say -infinity to +infinity, but because it's not, you can never be equal to positive or negative infinity by mathematical standards, you could say it like that. So that's number 1. Domain and range problem number 2. It's the same problem as number 1 was, but notice there's a hole. And this hole has a coordinate of 1, 2. So I'm going to start with the domain. Now, if you liked all real numbers, you could say all real numbers, all real numbers except x equals 1. So you're saying that it works everywhere except at this one value where there's the hole. If you're going to use the math symbols, you would say capital R to show that that it's all real numbers, but then you'd also mention x can't be equal to 1. So all real numbers except x can't be equal to 1. It's basically saying this exact same thing, but just not in words. You could also say, because it goes from -infinity, and it cannot be equal to -infinity, so soft bracket, it exists from -infinity all the way up to 1, but it doesn't exist at 1. So you put another soft bracket. But then it also picks up right at 1, so it goes from 1 all the way to infinity. And then in between it, you'd put a U. U stands for union. We'll talk more about that at a future date. At this point, just remember that it's just going to be a U that you're putting in there. Okay, I have some more examples. Example number 3. Oh wait, I haven't done range of number 2 yet. You have to do the range. Okay, so that's my domain for number 2. For my range, let me fold this over. For my range, you could same type answer as your domain, except this time the whole is at 2. So you could answer all real numbers except, now we're talking y values now, so except y equals 2. Using the math phrases, you could go all real numbers, comma, but y can't be equal to 2. You could also answer soft bracket, negative infinity, all the way up to 2, close, and it also works from 2 to infinity. Any one of these 3 answers is right. I wouldn't give all 3 of them. Whichever one you're most comfortable with, that's the way that you should answer this particular problem. All right, dramatic pause, then to number 3. Number 3. Okay, number 3. On this one, there's just a couple dots, or coordinates. When there's coordinates, it's a little bit, I don't know what the right word is, but and that one, you're going to make one of these big bracket things. I don't remember what these are called. But anyway, you'd put in this symbol, and then you list your x-coordinates, just the x-coordinates, smallest to largest. So -5, then an x-coordinate of 0, then an x-coordinate of 1, and then you close with the other end of it. And then the range, instead of looking at the x-coordinates, you're going to look at the y-coordinates, smallest to biggest. So starting at the bottom was -3. Oh no, my graph is inaccurate. If 5, -3 is here, that logically doesn't make sense that would be 0, -4. I'm going to move this dot down to here because I want to keep the fact that this is 0, -4. Sorry about that, everybody. Elliot makes mistakes too. So that means that this was actually inaccurate because my bottom number in my range was actually -4, then -3, then 2. Okay, example number 4, and I'm getting towards the end of my lunch break, everybody, so students are going to start filing into the room I'm worried about in a second, so it might get a little loud. So domain, on this one, it goes, the x values go from -5 to +4. For the domain, we only look at the x-axis. It goes, so the domain goes from -5 to +4. It can be equal to 4, so for 4 we put a hard bracket, but for -5 it cannot be equal to -5, so we're going to put a soft bracket. Moving straight into the range. So for the x-axis, for the domain, you're looking at the x-axis. So for the range, you're going to look at the y-axis. Bottom to top, this graph goes from -2 to +3. So I write -2 to +3. -2 had a closed-in circle, so it can be equal to -2. The top end of the range was an open circle, so it cannot be equal to the y value of 3. And that, my students, is example number 4. I have one more example, example number 5. I'm going to have to go quickly. First student's coming right now. I'm filming, so keep it quiet. So we have a graph that looks like this. We have a parabola. Write out domain and range. Domain. These arrows, they're pointing forever up, but they're also pointing over to the right and to the left. So this graph is going forever to the right and left. So it does go domain-wise all the way to -infinity, all the way to +infinity, at least on the x-axis. But infinity doesn't exist. So because infinity doesn't exist, we'll go ahead and put a soft bracket. Now with the range, bottom to top, the bottom of the graph occurs at -4. The top of the graph, it goes up and up and up forever. So we put infinity for that one. The graph can be equal to -4, so we're going to put a hard bracket on -4. The graph goes up forever, so we're going to put a soft bracket on the range. And that's my last domain and range example for you. You might want to take a look at the worksheet and the book problems we're going to work on in class before class tomorrow if you're interested. If not, have yourselves a great night, and I'll see you on Monday morning for practice on function notation, domain, and range. Hello, fourth period. Goodbye, students. Oh wait, we gotta make Elliot big first, right? Gotta make Elliot big first. All right, bye-bye, everybody.